All right, so let's go ahead and get started. So this is our current assignment. So you're going to be doing a paired samples t-test. And before I get started, I wanted to just describe what it is and give you the assumptions, and then we'll jump right into the assignment. So the first things first, a paired samples t-test is a statistical test that compares the averages or means and standard deviations of two related groups to determine if there is a significant difference between the two groups. They are related in a sense, and this is one of the assumptions that you're just going to have because you're doing a pre and post test on the same group of individuals. So because of that, they are inherently going to be related. They also have the same conditions, and so you have, like, for example, let's say you bring somebody into your lab and they do a creativity test. Maybe they have to draw a picture like we've seen before. And then 5 minutes later, after drawing the picture, you introduce something inspiring to them. Maybe it's some inspiring music, or maybe it's an inspiring image of something from American history. And then after they see the inspiring image, they take another creativity test. And what you do is you take the difference between the pre-creativity test and then the post-creativity test, the post being after the experimental manipulation, which was the inspiring stimuli, inspiring message or picture or image. Right, so here are the assumptions. The assumptions are, of course, random and independent sample, and we've gone over this before. The dependent variable needs to be approximately normal distribution, and we'll look at that next time we meet. We'll look at how to fulfill that assumption. And the dependent variable needs to be continuous. And I think those are all the assumptions right there. Now we're going to go ahead and jump into this assignment. So here's what we have. We have this situation where this professor is giving he's given a political science class, and as you see here, the professor Akhtar would like to know whether the undergraduate's political science class n equals 40. I'm going to write down 42 because I've changed this, so my data is going to be different than your data. So he gives them a political science class, whether it changed students' interest in politics. The professor assesses the students' interest at the beginning of the semester and then again at the end of the semester using a 5-point Likert scale. So this is a continuous measure that we can use. It's not, it's kind of a pseudo continuous measure. It's more of an interval ratio, but that's going to be our dependent variable, is the interest at the beginning, or I'm sorry, their interest in politics. So how interested in politics they are from a scale to 1 to 5. I am not at all interested in politics to I'm very much interested in politics. So the question is, was students' interest in politics different after taking the political science class? So that's the question. So the first thing we want to do is I'll give you time to think about how you'd write the null and alternative hypothesis. All right, so this is how you're going to do it. So you have one group right there, and mu is going to be the estimated population mean, and this is going to be pre. Test, and then equals post test. I probably should write this consistently in the same color. That's essentially what a paired sample t-test is looking at. But the sake of our examples, for the sake of our example, we're looking at, in this case, if I'm going to erase this right here, the pretest is going to be, in this case, interest. In politics. So interest in politics before taking the class. And then interest in politics after taking the class. So this is how it's going to look like. So we have before right here, and then after taking the class, and we are essentially taking the difference between the pre-test and post-test. That's what SPSS is going to be doing. And then if we're going to write down the alternative hypothesis, the only difference is they will not be equal. So let's say if we were to change this to the alternative hypothesis now, then what we're doing is we're saying that these groups will not be equal in some way. All right, so let's go ahead and move on to the next part of this. Conduct a two-tailed repeated measures t-test with pre and post interest in politics scores on the SPSS using alpha 0.05. So since it doesn't give us an alpha, we have to assume that it's 0.05. That's the convention that's assumed as alpha is 0.05. And also, we are not given a direction of whether it's going to improve their interest or not improve their interest. And so in that regard, what we have is a two-tailed test. So what we're going to do in order to get this information is we're going to go into Analyze, Compare Means, and then Paired Samples t-test. This is a repeated measures t-test, but it's in SPSS, it's called Paired Samples t-test. And I've already did this, so I'm just going to repopulate this so that you can see it in real time. So I'm taking the pre-test, moving over to variable 1 box, and I'm taking the post-test and moving to variable 2 box. All right, and then effect size is checked off, and then we're going to press OK. All right, so what do we see here? We have their mean score pre-test before taking the class, and their mean score after taking the class. And we also have the end value right there. So in my sample, I have 42 participants in this sample. So just looking at this information here, and this is what we're looking at for this particular portion of this assignment. So we're looking at this information, how many participants that we have, and it looks like here in my data set we have 42. And we're also looking at their pre-test scores and their post-test scores. These are the two things that we're looking at, and that's what we're comparing. And so as you see here, we have 42 participants. Their standard deviation is for pre-test or before taking the class is 1.246, and after is 1.297. And then there's a little bit of error. So, all right. Let's go ahead and move on to this part right here, because this is the important essential information that we need. So in this case, we're looking at this paired sample t-test, and we have the following features. We have the t statistic right here, negative 2.153, and then we have the degrees of freedom. So when we are using a paired sample t-test, a repeated measure t-test, we only have one group, and we have this population here, right? This overwhelming population, right? And we can't get everybody from the population, so we take a sample. And this sample is not divided into two groups. This is not what happens, but instead what we're doing instead, we are taking the sample and we're saying, okay, we're going to give you a pre-test, and then we're going to give you a post-test. Same sample. And then there is this area right here, which is the manipulation of some sort. In this case, the class is the manipulation or the difference of stimuli they receive. They receive something that is different from the pre-test and post-test conditions. In my classic example, I give somebody a photograph or read them an inspiring letter, and maybe that will inspire them to be more creative in their post-test creativity task. So that's what we have here. And if we think that there is going to be a significant impact in the positive direction of interest, that the class is going to make students more interested in politics, we would expect T to be negative because we're taking the difference from a smaller mean minus a larger mean. And in this case, since we only have one group, and I should have mentioned this before, it's n minus 1. And we have 42 participants, and minus 1 equals 41, right? And that's going to be our degrees of freedom. So we have a significant p-value, and this p-value right here, we write this as p equals 0.037. And that is our p-value, 0.037. And we also have information about the confidence interval, and here is the confidence interval. And we have the confidence interval for the effect size. And this is going to be our effect size right here, the point estimate, not the standardizer. Because how you're going, if you were to hand calculate this, which we will not hand calculate this because we're going to be using SPSS, all you need to do is put the t statistic in here, in this place, and then divide it by the square root of n. And that will give us this value right here. All right, so let's go ahead and move on to the rest of this assignment here. So we conducted that, and what I'm expecting for you to do is to make a screen capture of this, is to show that you did it. And you can just, something like this, I guess, where I just did control print screen on my PC, and then I went ahead and pasted this in, and I just want to see that you have these values, that you were able to successfully do this in SPSS. So now that I have this, and I can just sort of check it off and say, okay, great. Look at this right here. He or she did this, and I know that they're able to do this in SPSS. Now the next thing that you need to do is report to Cohen's D, and you need to successfully interpret this portion of your output, which is the point estimate. And so your Cohen's D in this case is going to be 0.33. And it doesn't matter if it's negative or positive, it's an absolute value in this case. And we know from Cohen's D that a value of 0.2 represents a small effect. And we know that a value 0.5 represents a medium effect. And then we know a value of 0.8 represents a large effect. So in this case, is the effect size meaningful? It is a small medium effect. And my judgment